What do we have today, minions, math magicians, aspiring geniuses all? What do we have? We have an integral to approach. Now, we got some sines, we've got some causes. The eagle-eyed ones amongst you will notice, whoa, what do we got going here? We've got some sines and causes. There's no squares, there's a denominator. It's feeling a little bit like it's time to deploy. The t is tan x over 2 substitution. Now, for the make benefit, let's take a second to see what that does for us, right? We have some general results that we may or may not remember. I very rarely remember them. So let's see if we can derive a few things about this substitution. Sine x is sine of 2 times x over 2, which is 2 sine of x over 2 cos of x over 2. And then, tell you what, cheeky red pen, we're going to multiply this by sec squared of x over 2 and divide it by sec squared of x over 2, which is going to give me 2 tan of x over 2 on top. Now sec squared is 1 plus tan squared, so that is 2t over 1 plus t squared. Isn't that nice? Cos x, now using that same idea of writing cos x as 2 times x over 2, that is, tell you what, that is cos squared x over 2 minus sine squared of x over 2. And we're going to do the same trick. Multiply by sec squared x over 2 and divide by sec squared x over 2. And by the same logic as before, that gives us 1 minus t squared over 1 plus t squared. And then finally, we probably need to figure out what's going to happen to my dx. Now, we could just go instead dt by dx. So tan, that will be 1/2 sec squared x over 2. So that is 1 plus t squared over 2. And now we have everything we need to substitute into here. Of course, sec squared is 1 plus tan squared, and there we go. Of course, we want dx. We're going to have to rearrange this a little bit, but we can do that. So what does this thing become? We get, now we'll deal with these in a second. Well, actually, we can do it straight away. If x is 0, t is tan of 0, which is 0. If x is pi over 2, t is tan of pi over 4, which is 1. Right, now, sine x is 2t, so that will be 6t over 1 plus t squared plus 4 times, there we go. And then if we rearrange that, we will get that dx is 2 dt over 1 plus t squared. Right, we've used all of that. All the hard work, gonzo. All right, here we go. Stuff. Let's try getting rid of the stuff. What we're going to do is we're going to multiply this denominator all the way through there. So what do we end up with? There's a 2 on top, so that's nice. I end up with 5 times 1 plus t squared. I'll end up with a 6t and a 4 times 1 minus t squared. Okay, all right, okay. So what does that give me? Anything fun? The whole point of this now is instead of having this mix of sine x and cos x, I've now just got a nice bunch of polynomials, right? All a bunch of powers of t, which opens up my avenues of integration techniques without having to deal with what is quite frankly a massive pain in the gluteus maximus. That is a mix of sines and coses. All right, t squared. 5t squared minus 4t squared is t squared. How many t's? There's 6t. Well, that's nice. That's nice for them. Plus 9. Ooh! I mean, interesting. 0 to 1. We can complete the square on that. Easy peasy, squeeze the lemon. Right, now, that integrates all nice like. I do believe that just becomes minus 2 over t plus 3. So what does that give me? It will give me minus 2 over 4 minus 2 over 3. Isn't that right? Now what's that? That's a half. So it's 2/3 minus a half. That'll be 6's, won't it? 4/6 minus 3/6. It's 1/6. Of course it's 1/6. Et voila! Which is where that lovely t substitution, also known as the Weierstrass substitution, will help us go from horrible, nice. Horrible, nice. Very good. Nice little bit of maths, really cool substitution. How anyone came up with it in the first place, absolutely beyond me. But there we go. We stand upon the shoulders of giants. Who said that? Apart from me just now. Anyway, don't forget to subscribe, like the video, hit the bell so you get notifications. Drop us a comment. What do you think? Hope you enjoyed it. See you next time.